All right, so welcome back. Part three, Transmedia, the deep media archaeological history. Um, so now, in light of what we've said here, I want to sort of push your thinking around transmedia in a new direction and say transmedia, perhaps it's not simply the incidental circulation of content from one mode to another, from film to television to the internet or something like that. Um, but instead, it's something like its origins and maybe even its practice today um, are about the ongoing composition of living bodies, platforms, and writing systems into kind of hybrid assemblages. It's rather about putting bodies and machines into real time interaction, right? Because in a sense, um, it's really around this problem of a field of battle where you have bodies and machines interacting in real time that you develop the first interactive computer machines. You develop the first visual interfaces for computers. You have the first audio interfaces for computers. And gradually, you develop modes for these computers to interact with other types of media inputs, say radar systems that are bouncing sound waves off the horizon to look for planes and so on, right? And when contemporary, say, developers of computers or designers look back to people like Sutherland as or Licklider as the early theorists of multimedia interaction among humans and machines, as the early developer of techniques for multimedia interactivity in computers, you're really looking back not just to a couple of guys who had some brilliant ideas or something like that, but rather you're seeing a set of scientific and media techniques that developed out of the peculiar situations of World War II. Now, there is, in fact, a little bit of a deeper history for some of this. I'm going to try not to go into too much depth and detail about it, but what the computers are really doing in this system when they learn to automate and circulate observations of the battlefield across multiple modes, it's putting in digital format things that already existed in analog format in prior decades. So here, for example, we see a slide of a battleship from the 1910s. And in this battleship from the 1910s, you had one of the first battle systems developed to enable lively real-time multimedia communication between people above deck and people below deck. That is to say, this is a pretty hard graph to explain. To tell you the truth, it's a lot easier when I'm in the room and I can point to the different parts of the graph. But what you see here, among other things, are various people above board who are, for example, manning guns or manning lookout towers. And all of the guns in the towers, as well as a central control room below deck, are linked together by electrical wires that are sending bits of, it's hard to explain, but basically electrical information that's translating what everyone sees into different formats. And then, for example, you'll see in the bottom left corner, there's something called a battle tracer. Here we see it a little bit better. The battle tracer would create a real-time picture that shows where the boat is, its movements, its relationship to other things in the battlefield. And the picture it generated in real time was produced by an analog computer. So this is before you had digital computers, you had analog computers that worked with rods and wheels rather than numbers. And that analog computer was, in effect, processing multimedia data, right? So here we see some of the types of data that were the data gathering devices distributed across the ship that would enable it to collect information and ultimately target enemies in real time. So you have on the left side a target bearing transmitter that is something, a kind of telescope that you could use to identify an enemy. Then you have image number 2, a director scope, which identified the enemy at sea and the motion it was moving in. Then you have image 3, a miniature computer that would calculate the movements of the plane, of enemy ship at sea. And then you have image 4, which is a time flight clock, which is something that would measure out time for the people above board so that they would know how much time had elapsed and be able to fire weapons at the right time to ensure that the artillery from the ship reached the enemy ship and destroyed it. So all of these elements are interacting in real time. They're sending information to something that produces real-time images, and they're all part of a single integrated system of communication for battles as far back as the 1910s and the 1920s at sea, right? So already in this kind of early stage, we start seeing the rise of multimedia systems. We start seeing methods of transmitting information between multiple modes, abstract, mathematical, visual. Here in the bottom right, we have a flight clock that uses audio, and so on. And so all of these systems that were born of 20th century warfare at sea, the fact that new types of ships moved quite rapidly, they could easily fire weapons at kilometers of distance. Out of this, you developed real-time interactive systems that could translate a single bit of information into multiple modes and transmit it in real time. Gradually, these technologies, these methods get repurposed, they get expanded in the course of World War II with radar defense systems. I'm not going to say a whole lot about this, but these radar defense systems, for example, end up developing new types of mapping technologies, new ways of seeing a battlefield in real time. In the top right there, you see a radar screen, and behind it, you see a photograph of what the radar screen represents. And so the conditions of battle in World War II end up producing this proliferation of new types of screens, new types of mapping methods, new types of information systems, as well as what we see here, new types of control rooms. So in this control room from the 1940s, that's actually happening inside of a trailer. You see on the left, you see multiple operators sitting at interfaces that were processing signals from the battlefield collected by radar. On the right, you see humans working with analog maps. And there's just sort of cooperation in real time between the computers on the operators on the left, the humans working with maps on the right, and, there goes another alarm. And what you see here, soldiers out in the battlefield charged with shooting down planes. And in fact, that square box you see more or less on the right side with someone sitting at it and someone standing at, that is an analog computer, right? So the history of interactivity, the history of multimedia computers, it doesn't even really trace back simply to the 50s and 60s with Sutherland, with Licklider. It goes even further back, definitely to the 40s, and probably as far back as the 10s and the 20s. And these systems in the 10s and the 20s, in the 40s and 50s, created new forms of observation, new forms of watching the battlefield, where information would circulate in real time among teams, among screens, among graphical maps. It would be transmitted in real time to computers in the field. It would be used to shoot down planes. Okay, so far so good. Well, some of the things I've talked to you about today here suggest how a condition of mid-century battle produces new types of multimedia interactivity that create a kind of, let's say, germinal, an early stage of transmedia. Now, I also started suggesting associated with this are new types of psychology, right? We saw that, for Sutherland and for Licklider, they're not just developing new types of interfaces, they're also interested in the new types of psychologies that are appropriate to these machines. So already in these mid-century World War II systems of radar, you actually you see the development of new types of psychological testing, new types of psychological training that will allow for the successful integration of humans and machines. Here we see one example of that, right? So what we're seeing here are examples of tests deployed given to the operators of these radar systems I'm describing. So on the left, for example, you see a map. Below it, you see small sections of that map. And in this particular test, would-be radar operators were tested on their ability to correlate small pictures, small glimpses of a larger image to how do you just say this? To take the close-ups and to correlate them rapidly with larger scale mappings or photographs of an entire area. And the ability of soldiers to rapidly correlate different types of visual information was one test of whether or not they would be good operators of radar machines. So within these large, complex multimedia systems, you need particular types of operators that can move back and forth between different types of visual and other representation and correlate them and integrate them. It's not just the machines here that are processing images, that are processing data, but it's also humans. On the right, you see a different form of visual test where the soldiers would receive, for example, the circle at the top left or the circle at the bottom right that has dots located somewhere within the circle. And for a test, they would have to say which letter on the circle in the middle do these dots correspond to. The ability of a would-be operator to correlate the dots in the top left and the bottom right to the letters in the center was a testing of their ability to do a certain type of information processing alongside visual processing, visual identification. So again, I'm emphasizing the point here that the rise of transmedia, the rise of new regimes of interactivity is not just about, say, coming up with a machine that can translate information between one format and another, but also developing new types of users and new types of psychological testing for these users that, how do we say it, that is also, say, converting, translating media between different formats, different modes, different scriptural systems, written formats, photographs, and so on, right? I'm not going to say a whole lot more about these particular images, except to say the testing wasn't just of their visual and cognitive skills, but also you had tests that of would-be members of these systems' physical skills. Could they fly planes? Could they navigate in flight simulators and things like that? So it was a whole package, right? The 1940s radar systems are not simply about computers or machines representing abstract information. They're not just about humans being able to cognitively manipulate or translate information between one mode and another. It's also about the physical competencies, the physical performances that might, for example, navigate a plane at the same time. So this is part of what I'm saying when I say we think about transmedia. Maybe we should step back. We should get away from this simple idea of thinking about transmedia as, what would you call it? Content circulating across platforms or something like that, and instead think more about situations, circumstances that bring together bodies and machines and images in new configurations. And out of that, you get the SAGE missile defense system. You get, let's see what we have here. The square that's on the left side of this screen. The square that's on the left side of this screen is where you have the operators of these particular interactive systems. And those operators are operating within this larger distributed network that we saw and thought a little bit about in the first 20 minutes. Okay, so we've got an expanded field of reference for thinking about transmedia. We see some reasons that transmedia develops out of a particular field of battle, a particular warfare situation, characteristic of 20th century battle. We also see some hints and clues as to how this developed new types of psychology. Some more clues as to how and why this developed new types of psychological and cognitive theories. Some of that is illustrated here, where we see the 1950s simulations that were used to train the teams that ultimately worked in SAGE defense networks, right? So these simulations that were conducted by RAND, a type of military think tank, would basically put soldiers in simulated air attacks, and they would observe how the soldiers interacted with each other in these highly stressful simulated attacks by planes and other military elements And observing these simulations would be teams of sociologists, teams of psychologists, who would come to understand a couple of issues. How is it that humans respond to stress? How is it that information circulates among teams as they're responding to these stressful situations? And out of that, you would see a whole range of innovations that are important for the development of late 20th century software, computing, human-computer interaction. So, for example, these simulations are conducted by the Systems Research Laboratory at the RAND Corporation, which in the course of, I think it's the early 60s, could even be the late 50s, actually becomes an independent corporation called the Systems Development Corporation. The Systems Development Corporation in the course of the 70s, probably well into the 80s, becomes the largest software company in the world, right? Because the reason that you have the largest software company in the world come out of these simulation systems for the Sage Missile Defense System is that these simulations provided some of the first, earliest realistic models of how humans and machines interact in real time, and that became the basis for figuring out how corporations could have teams of dozens or hundreds or thousands of users interacting in real time, a problem that deals with psychology, a problem that deals with sociology, and a problem that ultimately demands design solutions, the development of lively interactive interfaces that are somehow going to translate information across these vast teams. So in a way, the missile defense systems of the 60s, you could even go back to the 20s, but say, battle scenarios. But the radar defense systems of the 60s become the laboratory on which much 1970s, 1980s, 1990s theories of software are developed, implementations of corporate software programs, they grow out of these programs, and ultimately, the practical problem of designing lively human-computer interaction also grows out of these vast projects that intermingle psychology, computer science, electrical engineering, visual design, elements even of art and photography. All right. Now, as a kind of footnote, I am going to say that this type of work, this type of research also spun off into even bizarre, stranger fields, right? So for example, in the 1950s and the 1960s, you see the rise of a new type of psychotherapy that's called family therapy. Here we see a scene of family therapy interaction. And family therapy interaction was based on understanding psychology, based on understanding individual mental disorders as a result of interactions not among, say, elements inside the brain, but among people interacting with one another. In this case, mental illness was understood as being a product of real-time members of a family interacting with one another. And the way family therapy worked, at least in some of its iterations, not all of them, was to record families in real-time situations. So here you see a family in a kind of recording studio interacting with one another. You have audio recorders, you may well have film recorders, documenting them, and to more or less study them, to model them, much as you would model the radar defense systems in the 50s and 60s for the Sage missile defense system. So family therapy, which is still a thriving psychotherapeutic specialty today, develops in connection with, it's not a direct to, but in connection with these same type of human-machine systems. Let's see if I can show you another picture quickly. Here, for example, you see some of the early family therapy studies of interactivity that were modeled on what we see in the back right, studies of soldiers interacting with one another, right? And this is happening in the 1950s as part of that broader milieu of Sage missile defense and other types of new thinking about human-machine interaction. I'm going to more or less wrap up here, but in closing, I've told you a little bit about some of the basic concepts of transmedia, that it's a circulation of content across platforms, how and why. I've said that we might want to think about this concept as actually coming out of 20th century warfare and the particular circumstances of that, large machines interacting rapidly across great distances where you needed new ways of circulating media rapidly between formats, between sites. And out of that, you also get new types of psychology, new types of theories of cognition, human interaction that also become the basis for basically late 20th century software design that inform human-computer interaction and are with us today. And so these are not entirely identical with what we'd call transmedia today, but you could call it something like the background conditions, the history out of which contemporary real-time circulation of content across platforms thrives and circulates. All right, thank you for your time. Take care.